Every time we watch a film, something crazy happens. Hundreds of strangers sit in a dark room staring at this very screen that they have in front, and for a few hours, their hearts, their eyes, their thought begin to move as one. And it's not even poetry, it's biology. We think of cinema as emotions, storytelling, imagination, art. But what if it's also a form of neuroengineering? The technology that doesn't just show us the reality, but shapes the way how our brain perceives it. From the moment the first cut appeared on screen, from Eisenstein's montage to Hitchcock's close-up, from Tarkovsky's long takes to the flicker of your phone, filmmakers have been experimenting with consciousness. They've been manipulating attention, emotion, and time long before neuroscience ever had a word for it. What if every edit you've ever seen, every glance the camera directs, every silence before the scare is kind of a brain experiment? That's what a small group of neuroscientists discovered when they pointed fMRI machines not at test subjects but at moviegoers. They found something extraordinary. When people watch the same film, their brains synchronize, not metaphorically, but literally. Same regions lighting up, same patterns of thought, same timing, as if the film were conducting them like an orchestra. This is what they call neurocinematics, the science of how movies move the mind. Before I start this episode, I just want to make a disclaimer that this whole episode is based on Uri Hasson's research, and I would really love if you read his paper as well, which is linked underneath. And yeah, back to the episode. Long before the term neurocinematics existed, filmmakers were already experimenting with the human mind, intuitively and instinctively. They didn't have fMRI machines or EEG scanners, if you will, but they had audiences with them. Every screening was an experiment, and filmmakers were the early neuroscientists of emotions, if you will. Eisenstein believed that editing wasn't just a storytelling tool, it was a psychological weapon. He called one of his attractions of montage intellectual montage, which meant two unrelated images placed side by side could create a third meaning, not on a screen but inside your mind, inside the viewer's mind. Then came Hitchcock. He knew exactly where your eyes would go before you did. He famously said, "The size of the image determines the emotion."
So I have this man mounting the stairs in what we would call a medium shot, a waist shot. And he gets to the top of the stairs. Then I take the camera and put it very, very high. Way, way high, above the ceiling almost, as though we're looking down on the whole thing. And a little figure runs out with a raised knife. And the hand goes up with the knife into the air and starts to bring it down. Now remember, these are two tiny figures. Then the next cut is a big head of the man as the knife goes across his face. Now, this is size of image put together to create shock.
He played the audience like an instrument. Decades later, neuroscientists like Uri Hasson at Princeton actually proved that. They scanned people's brain while they watched Hitchcock's Bang You're Dead, a short TV film. The results were astonishing. Almost every neural activity synced. Their attention, emotion, and memory aligned in near perfect rhythm. It was as if Hitchcock himself were conducting their neurons frame by frame. And then Tarkovsky broke that rhythm. His long takes and meditative pace don't hijack the nervous system. They ask it to slow down, to breathe, to feel duration itself. If Hitchcock represents neural synchronization, Tarkovsky represents neural expansion, the space where thoughts and images coexist. And to me, that's a fascinating paradox of neurocinematics, if you will. Both Eisenstein and Tarkovsky manipulate attention, one through collision, one through contemplation. When Uri Hasson published his paper in 2004, the word neurocinematics was coined. He found that when people watch narrative films, their inter-subject correlation, the similarity in brain activity between individuals, increases dramatically. In simple words, a well-directed film can make dozens, even hundreds of brains think together, but not all films do it equally. Tarkovsky's Stalker synchronizes people differently than Michael Bay's movie does. A montage by Eisenstein activates frontal attention networks, surprise, cognition, reasoning, etc. A slow sequence by Ozu or Bresson activates regions linked to empathy and self-reflection. In that sense, a director is more than an artist. They are architects of collective consciousness. The audience's brain becomes the final screen. When you sit in a dark room, you think you're watching a film. But from your brain's point of view, the film is watching you as well. Every flash of light, every sound cue, every cut sends electrical impulses rippling across billions of neurons. And what's extraordinary is that across hundreds of people, those ripples line up. That's what Uri Hasson and his team discovered in Princeton in 2004. They called it inter-subject correlation, or ISC for short. It means that when many people watch the same film, the same region of their brain activates in the same rhythm. When participants watched the good, the bad, and the ugly, their visual cortex, auditory cortex, and superior temporal gyrus fired in near perfect unison. When the film became suspenseful, the amygdala, the emotional center, synchronized too. It's as if a movie was conducting an orchestra made of brains. And that's what separates film from almost any other art form. Maybe not gaming, but paintings, novels, or music can evoke a range of interpretations, but film, especially tightly edited films, produces something closer to shared cognition. It aligns perception and emotion across individuals. Uri Hasson tested this directly using Hitchcock's Bang You're Dead. He found that Hitchcock's editing, with its careful rhythm of suspense and release, generated the highest level of brain synchronization ever recorded in his lab. Every viewer's attention was locked in the same temporal pulse. Compare that to when subject watched unstructured reality footage or random visual notes. The synchronization collapsed. Without narrative, the brain drifts, it wanders away. That's the hidden genius of storytelling. It doesn't just entertain us, it organizes the mind. But not all films seek total control. Some, like Stalker or Tokyo Story or any Kiarostami film, if you will, lets the brain breathe. They invite what neuroscientists call default mode activation, the network associated with introspection, daydreaming, and emotional empathy. Is the space that the mind enters when it's allowed to drift. That's why slow cinema feels meditative. It's not forcing synchronization, it's entraining self-awareness. Instead of pulling all brains into one tempo, it lets each viewer find their own. And that might be why these films stay with us longer. They're less like commands and more like invitations, if you will. So inside the theater, two kinds of minds are always at work. The synchronized mind, marching on the film's rhythm, if you will, and the second being introspective mind, wandering within it. Both are cinema, both are neurocinematics, and both raise a deeper question. If film can coordinate what we see and feel, can it also shape who we are when we leave the theater? Editing isn't just a film technique, it's a grammar of how our brains make sense of time. Long before cinema, your mind was already cutting, stitching together fragments of sight, sound, and memory into the illusion of continuous world. We never see everything at once. Our eyes start, our focus shift, and in between every glance, your brain performs a miracle. It fills the gap. That's basically editing. A cut between two shots isn't alien to us, it's native. Psychologist Jeffrey Jack calls this event segmentation theory. He found that our brain naturally divides life into scenes, like camera pairing sequences, if you will. When something changes dramatically, movement, light, or tone, the brain drops a mental cut. And when the next shot appears, it predicts what should happen next. If the film meets the prediction, we stay immersed. If it breaks, we jolt. Directors like Eisenstein understood this long before neuroscience caught up. He wrote that montage wasn't just about linking images, it was about collision, the psychological shock between them. He compared it to synapses firing in the brain. A cut creates an idea that didn't exist before either shot alone. Today, brain imaging supports it. When viewers see two shots that imply connection, the temporal lobe activates to infer meaning.
Now we have a close-up. Let me show what he sees. Let's assume he saw a woman holding a baby in her arms. Now we cut back to his reaction to what he sees. And he smiles. Now what is he as a character? He's a kindly man. He's sympathetic. Now, let's take the middle piece of film away, the woman with the child, but leave his two pieces of film as they were. Now we'll put in a piece of film of a girl in a bikini. He looks, girl in a bikini, he smiles. What is he now? The dirty old man. He's no longer the benign gentleman.
That's the Kuleshov effect, and it's literally measured in neural terms. Context reshapes perception. Our neurons don't just watch the film, they complete it. The predictive dance is what keeps us glued to the screen. Every edit is a test. Your brain predicts the next frame, and when it's right, it rewards your dopamine. When it's wrong, it spikes adrenaline. That's the subtle rhythm of attention. Control and release. Fast cutting keeps our attentional network in overdrive. Every 2-3 seconds, a new visual task resets the focus. It's stimulating, even addictive to a point, because it constantly refreshes our sense of novelty. But over time, it also fatigues the prefrontal cortex, a part responsible for sustained attention. That's why film with rapid editing feels thrilling but exhausting as well. Slow cinema, on the other hand, engages the default mode network, the brain's reflective space, if you will. When a shot lingers beyond what we expect, we begin to wander inside it. We notice sound, light, gestures. At least I think that's why Tarkovsky called cinema sculpting in time. He wasn't just being poetic about it. He was describing how duration itself shapes consciousness. And here's what makes it fascinating. When neuroscientists measure audiences' brain during slow meditative films, synchronization doesn't vanish, it shifts. Instead of a sensory region aligning, the emotional and introspective ones do. It's not about collective attention anymore, it's about collective reflection. That's editing too, to be honest. Not of images, but of thoughts. Every filmmaker, consciously or not, becomes a neuroengineer, if you will. They play with attention, memory, prediction, and emotion, crafting a choreography of the mind. But this synchronization of minds, this delicate control, raises a question that sits in the heart of neurocinematics. How much control should a film have over the viewer's brain? Should cinema command attention or invite us? When we sit in a dark room staring at the glowing rectangle, if you will, our brains begin to mirror. We don't just see, we simulate. This is the foundation of what neuroscientists call embodied simulation. In the mid-1990s, researchers in Parma, Italy, Giacomo Rizzolatti and Vittorio Gales and their team discovered mirror neurons in the premotor cortex of monkeys.
My interest was in describing the organization of the motor cortex from the point of view of the input coming into this region. So we studied how the monkey and the motor system react when we present object. And our first discovery was that in the motor system there are many neurons which fire when the monkey observes an object. Now these neurons are known as canonical neurons, because what they do, they are transforming the affordances present in an object in a way you can grasp it. For example, you have a small peanuts, you grasp like that, and it's enough to observe the peanuts that you immediately have already in your mind, in your brain, how to grasp it. This visual motor transformation is made immediately in the parietal lobe and premotor cortex.
These neurons fired not only when the monkeys performed an action, but when it saw someone else perform it. In humans, the same system connects to emotional and sensory regions. So when we see someone on screen crying, sweating, trembling, if you will, our brains partially recreates the experience. The same circuits activate as if we were crying, sweating, and trembling. Cinema then becomes a neural simulation of life. In Uri Hasson's Princeton fMRI studies, this phenomenon is visible. Literally, when multiple viewers watch the same emotionally charged scene, the brain actively synchronizes across temporal and frontal regions, the very network tied to empathy and meaning. Hasson called this neural coupling. The moment when film doesn't just tell a story, it aligns mind. In Hitchcock's Rear Window, the coupling is engineered. Jeff, the protagonist, watches his neighbors through a lens. We watch him watching, and in doing so, Hitchcock traps us in a loop of mirrored perception, a recursive empathy machine, if you will. Every reaction shot from Jeff calibrates our emotions. When he flinches, we flinch. When he doubts, we doubt. And it's not about empathy as sentiment, it's about empathy as architecture. Eisenstein predicted this decades before mirror neurons were discovered. He said that montage operates on Patho's formula, an emotional transfer between spectator and image through rhythm and movement. He was describing neural resonance before anyone had the vocabulary for it. But there's a paradox here. The stronger the synchronization, the tighter the control. The more we feel together, the less we feel apart. That's the ethical question inside neurocinematics. If cinema can guide the mind this precisely, where is the boundary between immersion and manipulation? Because films don't just mirror our emotions, they can rewrite them. Take 2019's Joker, for example. Many viewers empathize not with a victim, but with Arthur Fleck, a man who descends into violence. Neurocinematically, it makes sense. Mirror neurons don't basically judge. They respond to motion and emotion, not morality. Camera don't ask whether he's right. It just asks whether he's human. And that's where we follow him, even when we shouldn't. But this power to embody others is also what makes cinema transcendent. In Tarkovsky's Andrei Rublev, we feel the weight of faith and doubt as if they were physical forces. In Cuarón's Roma, the camera's patience draws us into Cleo's world until her grief becomes our own. These films don't command empathy, they invite it. They slow us down enough to inhabit another mind without losing ourselves. Here's where neurocinematics meets philosophy. The German term Einfühlung, this word, I'm really sorry guys. This German term, the root being empathy, literally means feeling into. When you're entering a film's rhythm, you're quite literally feeling into the world. Cinema becomes not just a story, but a shared state of consciousness. And yet, our world of images is changing. Today, our brains are trained not by Tarkovsky, but from social media and TikTok, by microbursts of dopamine, by jump cuts, if you will, every half a second, by content optimized for retention and not reflection. Our neural architecture of attention, the very wiring that cinema once shaped, is being rewritten in real time. That doesn't mean we're losing empathy, but the way we experience it is fragmenting. Instead of one collective rhythm like the theater audience breathing together, we now live in millions of micro rhythms, all asynchronous. The screen that once mirrored us now splits us. If the 20th century gave us the language of cinema, the 21st century might give us the biology of it, because somewhere between neuroscience labs and editing rooms, a new kind of cinema is being born. At Princeton, Uri Hasson and Talma Handler began a simple question: can we measure storytelling in the brain? Later studies refined this idea with inter-subject correlation, a statistical measure on how much viewers' brain actively aligns over time. Films like The Good, the Bad, and the Ugly and The Match Factory Gold produces high synchronization during narrative tensions and loose correlation during abstract and slow scenes. What this tells us is not that some films are better, but it tells us that they tune the mind in different frequencies. Now imagine taking that principle and designing films for it. Eye tracking cameras already measure where audiences look on screen. Streaming platforms already use A/B testing thumbnails based on dwell time and gaze heat maps. The infrastructure for neurocinema already exists. We're not just calling it that yet. Prototypes of adaptive narrative are being tested. Cinema becomes not fixed but alive. And that raises a fascinating question. When films start responding to us, who becomes the editor? The director or the audience? For filmmakers, this could be liberation or loss. For scientists, it's a window of cognition itself. Because what neuroscientists really reveal is that storytelling isn't just an art form, it's a cognitive interface. Every cut, every frame, every beat of sound is a data point in how we think. But beyond the lab, there's another evolution already underway. The post-social media generation doesn't just consume cinema, it edits life like it, a distributed form of montage that millions of people perform daily. The cinematic brain is no longer in theater, it's everywhere. We've externalized editing. We think in jump cuts and we remember in flashbacks. We scroll through time, and that's not the death of cinema, it's a mutation, if you will, because the principles that Eisenstein and Hitchcock developed, rhythm, anticipation, and release, still drive how we experience the smallest videos online. The brain hasn't changed as fast as the culture around it has. We still are chasing coherence in a storm of images. And maybe that's the real promise of neurocinematics. Not to mechanize cinema, but to remind us how deeply it already lives inside us. So perhaps the future of neurocinematics isn't about predicting emotions. It's about returning to what made cinema powerful in the first place. A silent agreement written not in pixels or neurons, but in empathy.